Hey class, today we're going to be talking about VSEPR theory. So what is VSEPR? VSEPR is as follows: valence, shell, electron, pair, repulsion. So now what is the actual definition of VSEPR? So what VSEPR really is that it explains that the shape of a molecule is actually dependent on the number of lone pair and bonding pair electrons on the central atom in a Lewis structure. So essentially this means that a molecule is different from the Lewis structure itself. The shape of the molecule is actually dependent on the number of lone pair electrons and bonding pair electrons surrounding the central atom. So, what is the notation of VSEPR? The notation of VSEPR is as follows: AB subscript X E Y. So what do these letters stand for? A is the central atom, B represents the bonding pair electrons, E represents lone pair electrons, and the subscripts X and Y represent two different things. X represents the number of bonding pair electrons, and Y represents the number of lone pair electrons. Now we're going to talk about VSEPR rules. So these are the following VSEPR rules. Only the valence shell electrons are considered, and this applies for both the lone pair and the bonding pair electrons. The second rule is to assume that all electrons are paired. The third one is that lone and bonding pair electrons are all treated equally, although lone pair electrons do repel each other a little bit more intensely than bonding pair electrons, we still treat them as equal. Also, treat single, double, and triple bonds the same. All electron pairs repel each other electrostatically, and the last rule is that molecular shape is determined by the position of electron pairs when at a maximum angle apart, and this is called the lowest possible repulsion. So now, let's talk about molecular shape and polarity. So molecular shape and polarity. There are two factors that determine whether a molecule is polar or not. The first factor is the shape of the bond, and the second factor is the type of bond that makes up the molecule. So for example, molecules that contain at least one polar covalent bond in an asymmetrical shape are polar. Now we're going to start drawing VSEPR molecules. So when it comes to molecular shapes in VSEPR, there's 5 families we need to consider. The first one is AB2. What we can gather from this equation is that there are 2 bonding pairs and 0 lone pairs. So the diagram would be as following: central atom, 2 bonding pairs, no lone pairs. The angle in between them, because of the lowest possible repulsion, would be 180 degrees, and the name would be linear. So the second family is AB3, but it also comes in another form as AB2E. It falls under the same family as AB3 only because the sum of X and Y is still equal to 3. Now, the difference between these two is that AB3 has 3 bonding pairs, whereas AB2 has 2 bonding pairs and 1 lone pair. However, the lone pair is not drawn in the VSEPR diagram. The angles between the bonding pair and the lone pair are still 120 degrees for both diagrams. But the name of AB3 is the triangular planar, and the name for AB2E is angular. The third family we're going to talk about is AB4. Again, notice that the sum of X and Y all adds up to 4 for each of the sub-family parts. The diagram for AB4 is as following: a bonding pair going up, one to the side, and a hatch and a wedge. Hatch and wedges are drawn together, and they're used to depict three-dimensional space. So this means that the hatch is coming out towards you, and the wedge is going back out into the page. The angle between the bonding pairs are 109.5 degrees. For the next family and the following ones, you remove one bonding pair and you add a lone pair electron. But always remember that when you're drawing different structures, you can't have just a hatch or just a wedge. They have to be drawn together. So the diagrams are called triangle-based pyramid, angular, and linear. And each of these angles are still 109.5 degrees. The fourth family is AB5. The diagram for this is a triangle-based pyramid. The only thing tricky about this family group is that the vertical angles are 90 degrees, whereas the horizontal angles are 120 degrees. So you must remember when removing bonding pairs and adding lone pairs, you must remove from the horizontal before you remove from the vertical. So the first one is called a triangle-based pyramid. When you remove one bonding pair, it becomes a seesaw. Remove 2 becomes T-shaped, and when you remove 3, it becomes linear. The fifth and final family is AB6. The diagram for this one is a square-based bipyramid, and all of the angles are 90 degrees. When you remove one bonding pair, it becomes a square-based pyramid. When you remove 2, it becomes a square planar. When you remove 3, it becomes T-shaped, and when you remove 4 bonding pairs, it becomes linear.
To conclude, VSEPR is awesome and helps us understand the shapes of the different molecules. Thank you for watching our video, and don't forget, join Chem Club!